know, communicate with your instrument, which is on the ground, and those satellites give the vertical coordinates, z coordinates, x coordinates, y coordinates of any feature, whether that is a tower, whether that is a building, whether that is any kind of a natural feature or man-made feature, and your instrument or your receiver get all the information, and then that information you can give to your software or your whatever program you have, and that will plot the topographic survey for you. Obviously you will be able to select the scale in your software. And then there is a laser scanning. If that is a really complicated thing and there are so many little man-made feature, for example, if you see this bridge, you cannot survey this whole lines, or this is a factory with a lot of pipes, so you cannot survey each pipe coordinate or everything. So you use laser scanning. So laser scan, you scan it, you get the data by laser scanning, you give to the software, and software will automatically plot everything for you, right? Three-dimensional conformal coordinates transformation. I don't think you need to do this topic. Um, this is more of computer software problem, and you, if needed, you can use your software to do that rather than doing this by hand. Selection of the field method. How do you select the method? What method would be suitable for your survey? What is the purpose of the survey? Whether this is a detailed survey or this is a rough survey, or whether this is a survey for some very, very, important thing, or whether this is just to have an idea of topography of that area. So purpose of the survey is one thing which will define what kind of survey you should do. Map use, it means what accuracy is required. If it is a survey for flooding system, if that is a survey for a flooding system, few inch or few feet error is not a big deal. But if that is a survey to construct a rail line, you cannot ignore even a 1 inch error in that, because otherwise that whole structure would be useless after being built. Map scale. So map scale also define the accuracy. If it is a really small scale, that means you want really, really accurate map. If that is a really big scale, that means you don't care about 1 inch or 2 inch or 5 inch error. Contour interval. If the contour interval is like 200 feet, that means you are not really concerned about little mistake in few inches. But if the contour interval is like in 1 feet, you cannot afford 1 inch or 0.1 inch error in that kind of contour. And that also tells you that you want to capture every details, because you are having few feet contour interval. Size and type of a terrain involved. If that area is like 100 square feet, so that means you have to go really into detail, right? If that is a 1,000 square mile area, that means you don't care about little mistakes or little errors. Costs, like how much money you want to spend on that survey. If it's like 100,000 rupees survey, that means you cannot do much with that. If that is like budget for surveying is 10 million rupees, that means you have to do extensive and detailed surveys. Equipment and time available. If there is a very little time available, that means you have to ignore the smaller thing. If it's extensive and a lot of time for surveys available, that means you have to cover every and each detail. Experience of the surveying personnel. So if your surveyors are kind of inexperienced, they will have a lot of errors and problems. But if your survey party is really experienced people, that means they have less error. So all these are the factors which will help you to select the method, what method you want to use for your survey. Working with data collectors and the field to finish software. So this is all about automated data collection, like we were talking about those global navigational satellite system and something. Your receivers are getting that data, and then that data is being processed through your software, and then your software is using that refined data to build your maps. And now there are hydrographic surveys. Before we were talking all about what are the topographic surveys and what are the planimetric surveys, but all those surveys were about the surface of Earth. dry land. We were talking about the dry land, but now we are talking about the hydrographic surveys. So hydrographic surveys are the surveys which you conduct to measure the features underwater. Okay, or these you want to survey the water bodies. The water bodies can be lakes, can be ponds, can be seaports, can be rivers, can be canals, can be oceans, whatever. So two basic tasks involved in hydrographic surveys are making sounding, measuring depth from the water surface to the bottom, locating the position where sounding was made, right? So if that is a shallow, water body, what you can do, you can use, if it's a 10 feet, 20 feet deep water body in some pond or in some shallow lake, you can have a rod, 10 feet long rod, and you sit on a boat and you go to one position and you measure X and Y coordinates, and then you put your rod down and it touches the bottom of that water body, and you measure this rod is, graduated on the surface. So, it's a 9 feet depth, and then you go to another place and measure XY coordinate, and then the depth is 7 feet, and you go to another. So these are like really shallow thing, water bodies. So you measure the depth, the X and Y coordinates where you took that depth, and with the help of these three coordinates, you draw the maps like this, right? That that give you the features of the bottom of that water body, right? However, if the depth is more than 10 feet or 15 feet where you cannot use that rod, right? Then what you will do, you will use a cord, flexible cord. You will bind one on the one end, little bit weight, and then you drop that weight into water with that cord. It is for the semi-medium depth, like 20, 30, 40 feet, right? And once that weight, which is tied to the that cord that touches the bottom, you measure the length of that cord, and then with the help of that, you know what is the depth of that water body, and where you measured that depth of the water body, you also measure the X and Y coordinates, and then you build your hydrographic maps. Now, these are shallow or medium shallow water body. But what about like things which are really deep? So on those things, you use the same boat technique, but then you use, something which can, give sounding pole, or, which can give the, um, uh, some sound which travel through the water, touches the bottom, reflects from bottom of that water body, and then comes to your receivers, which are on the same boat. So the travel distance is the double distance, because it goes down to bottom and from bottom come back to your receiver. So you can divide by 2 and you can come up what is the depth of that water body. And then with the help of your other instruments, you can, measure the X and Y coordinates on that same point where you are using that sounding instrument. And with the help of sounding waves, which are going down to the bottom and reflecting back to the position where you produce that sound, that will give you the depth of that water body. So these are basically for deep water bodies. So you can use several kind of instrument for making sounds and getting back. And then with the help of that, you can locate those water bodies depth, and you can develop the maps, right? So this is mostly, the theoretical chapter. However, this chapter is important because when you develop those maps, whether those are hydrographic maps or whether those are contour topographic maps or planimetric maps, you should know all these theory to build those maps. All right. So this chapter is important because at some point I may, ask you guys to give me quiz, and that quiz can contain question from this chapter and some other chapters. Like, for example, I can say, can you explain to me if a contour can close with another contour? So you have to, if you remember the, how contours are made, then you will be able to answer that question. All right. So anybody who came later and his
Me, me, sir. Suresh.
who is me?
Me, sir.
When?
mining